With SimVSM, you can capture your value stream via drag and drop on a mobile device or in a desktop application. Quickly and easily create alternative modeling variants and analyze your digitized value stream with static KPIs already during modeling. The shown extensions of our value stream tool SimVSM are developed in the context of the DigiPrime research project. Started in January 2020 and funded by the European Commission, the project is planned for 4 years. As soon as the application is started and the user has logged in, the project overview is visible. To open a project, just click on it. The application itself is split in different areas. In the blue section on the left side, all the objects implemented for the remanufacturing process are listed, like the source, disassembly, or buffer push inventory. Also, several additional objects from the manufacturing process can be found and reused and even used in combination. Starting a new project, the modeling area would look like a blank paper. Adding objects to the project is done by simply using drag and drop. When adding a new object, the side menu on the right side of the application opens automatically, where the object can be parameterized. Types and number of parameters depend on the object. Before a new production value stream is created, some project settings must be done. For example, all the parts which are handled in the value stream must be added. This can be achieved via the Products and BOM button. Here, the desired products must be created, connected, and configured. The buttons at the upper right edge offer various help for this, like automatic layouting or searching for already created products. Also, a shift calendar can be set up and used. As soon as everything is prepared, the value stream can be set up. The present example is already covering the complete value stream. In this use case, 2 different products are delivered by 3 different sources. 1 product with oil and 1 product without oil. The product with oil is disassembled, the oil is drained and reprocessed. Finally, both products are prepared and shipped. Starting with the sources, the suppliers, from where these 2 product types are pushed into the value stream. More detailed information, for example cycle times, can be accessed by clicking on the single products. In this process step, the product is first cleaned before the contained oil is drained off and reprocessed in further steps. Afterwards, both products are moved to a buffer storage before they are disassembled into individual parts in this step. The respective good parts are then processed, and the bad parts are sorted out and destroyed. After reprocessing, the covers of 35% of the parts must be replaced, before all parts are stored in a warehouse. After that, the final inspection is carried out and the parts are finally transported to the customer. Parameters are not validated yet, but they already show the different functionalities and possibilities of configuration within the value stream. Here there are 3 different process steps for cleaning, again with various scrap rates and transfer quantities. Now the focus is put on these 2 process steps. In the disassembly core object, all incoming products are disassembled into their components. The bad parts are sorted out, the good parts are further processed in the next process steps. There is also a flag, exchange parts. By activating that flag, parts are split up into subparts in the bill of materials. This way all the single process steps can be specified and configured. The first static calculation is the throughput time, which is always provided within here, also for these remanufacturing objects. Briefly explained, the throughput time is a static calculation, done automatically, on how long it takes a part to move through a certain part of the value stream. That now was the first step to build up a value stream with these new objects. With the software SimVSM, it is now possible to start a simulation of this value stream by the click of a button. Now all the information from the front end is collected and sent to a back-end server, where a simulation process is started automatically, generating a simulation model, in this example in plant simulation. After the model is created and run, the generated information is collected, and the results are transferred back to the front end of the software. the progress of the simulation and be observed in this area. Once the simulation is finished, results can be viewed in here. In this example, the simulation ran 5 days. Now the simulation results, with the most important KPIs of the value stream, can be viewed here. For example, the process utilization for every process step with exact time percentage rates of the single process states. With the help of a process bottleneck analysis, it can be seen that the process, extracting fluids, might be a bottleneck in this value stream. Also, some of the customer orders completed within the specified time threshold are not satisfactory. Thanks to this analysis, the respective processes can now be looked at more closely and improved. It is also possible to perform several simulation runs with different setups. In this example, a new alternative was created, and the process, extracting fluids, is split up into 2 processes in order to resolve the bottleneck. A new simulation run was then carried out, the results of which can now be compared directly with the first run. By selecting the second experiment on the right side, a direct comparison of the simulation results is possible. Resources are still highly utilized, but an improvement of the utilization of the subsequent processes can be seen already, and also the bottleneck was shifted. Looking at the customer order statistics, splitting the extracting fluid process had a very positive effect. Another important reason why using value stream simulation can be very useful is that the dynamics of a system can be visualized very easily. For example, it can be analyzed, which part occupied how many storage capacity at which time. Working with this value stream and the remanufacturing objects offers the same capabilities as on the manufacturing part. A lot of functionality has been added with the new objects, and it is very easy to build up or document remanufacturing processes. The next step is to work on the use case to adjust it to the real world, to configure it with real parameters, and to validate the data and results based on the value stream simulation of such a remanufacturing line.